Next, we're going to talk about Chapter 5, Calculations for Sterile Compounding. So we've already done the pre-course assessment review where we've gone over calculations and the different primary types of doing calculations, whether it be ratio proportion, dimensional analysis. So this chapter is going to review those concepts as well. The beginning of the chapter with historical content talks about the origin of measurement, early systems of pharmaceutical measurement, including the apothecary system, the avoirdupois system, the household measure, and what we use today is primarily the metric measure. Also talks about some inconsistent methods of calculations, including pediatric calculations, Clark's rule, Freed's rule, Cowling's rule, and Young's rule. There is a comparison on table 5.1 of the different 4 children's dosing rules. We will review those because they do still turn up on the certification exam. So, calculation, regulation of standardization in practice is important. It helps to reduce error, and we really are trying to get away from those conversions of especially the apothecary system of measure. So in this chapter, the objectives are primarily to practice several different types of pharmaceutical calculations and determine the best method for solving the problem. Now, although the book is going to have you identify, in this circumstance, which is the best method, it's generally been my practice with students to tell them, find the system that works for you and stick with it. Apply it in all circumstances. And most of the ways that Miss Ashante and myself will teach you are something that will work in every situation, instead of trying to say, well, for this, I use this, but if I'm doing something different, I use something different. Stick with one, and it'll serve you well. So, the majority of the compounded sterile products will require calculations. So we saw the label in the previous chapter with gentamicin ordered. Well, it just told us how much gentamicin it wanted in the bag. It didn't tell us how much of our stock solution would give us that gentamicin. So we will have to do that calculation. We want to use logic in approaching math. So the ratio, proportion, and dimensional analysis help to do that. So looking at the protocols, calculations are done in the anteroom. We don't do them in the clean room because we don't bring paper in, we don't bring pens in generally, we don't bring calculators in, so we're going to do this ahead of time. Also, when we do that, then we'll know what do we need to complete our order. So it's kind of like a recipe where we have to determine how much of the additive to put in there. So the prescriber tells us that what they desire for the medication, generally what the base solution is, as I referenced in Chapter 4, that may be something that's in the pre-existing order set in the computer system, or something we have to go and look up if it's not specifically ordered. The desired amount, or the dose the physician wants, the interval, so is it given once a day, is it given every 24 hours, twice a day, every 12 hours, every 4 hours, and things such as that. The prescriber also determines the infusion rate for large volume parenteral, but note that most small volume parenterals are just administered over a standard amount of time, like infuse over 15 minutes type of thing. Once the medication order is received, we enter it into the information into the computer system, and we generate the label, and then we go back and we verify it against the original order. So I referenced that at the end of Chapter 4. We want to make sure that the information matches 100%. So you can also review in this chapter the common terminology and abbreviations that we use, milligrams, milliequivalents, micrograms, and such. So the calculations themselves, they're based on the information on the compounded sterile product label and by using the stock medication container. So we begin the calculation process by determining the concentration or the dosage strength of our stock solution. So here we have a stock solution of ceftriaxone. So what we would look at on this order, let's see, get our little pen here and take our highlighter. All right, so in this case, we've got 1 gram of drug, and we're going to use, we've got a single dose vial, but we need to look at what will be our concentration. So we have to read. So this is sterile, non-pyrogenic, preservative-free. Each vial contains 1 gram. Reconstitute with sterile water. Shake well for concentration of ceftriaxone. We're going to dilute with 10 with a final concentration of 100 milligrams per milliliter. So if the doctor had ordered 1 gram, we would drop the entire content of this vial. But we'll say that the order was for 750 milligrams. So then we would have to do a calculation. So we always start with what we know. We've got 100 milligrams per milliliter, and I need 750 milligrams. So how much will I need? So I've used ratio of proportion to set this problem up. So we'll talk more about how to solve these types of things in the upcoming slides. All right, so one concentration is that the volume in milliliters or liters and the strength, and if it's in a percent strength of the base. Those solutions are not included in our calculation. A base solution is not part of our calculation. That's just the carrier vehicle. So we need to know how much we're going to put into that. Now, sometimes we will need to determine how long the bag's going to last or how many bags we might need if we're doing an IV run. We want to cut down on waste, or we need to know when do we need to get the next bag to the nurse type of thing. We also may need to calculate drop rates or flow rates. Some special considerations, like I said, the base solution, but another consideration is calculations that an IV technician chooses the method or the formula based on the type of the CSP being prepared. Mostly it's going to be your personal preference, but we're going to go through the different 3 primary types of calculations. Before we do that, I want to talk about something we call the 10% rule. So in general, we don't usually worry about how much fluid we're going to put into an IV bag. If a doctor wants an antibiotic, most of them, we're just going to put the amount into the bag, and we're not going to think about the final concentration of the bag. However, in certain circumstances, that concentration is very, very important. It has to do with the stability as well as the administration of the medication. So especially with chemotherapies and TPNs, and on some occasions antibiotics, the CSPs required the technician to pay special attention to the total volume, and that should say final, concentration of the finished product because of stability of the admixture or dosing that's based on the concentration. So if we don't have the proper mix and we're dosing it based on what we perceive that mix to be, the patient could be underdosed or overdosed, generally underdosed. So the 10% rule is used if the amount of drug added to a base solution is greater than 10% of the bag's content. So what does that mean? That means if we need to inject 15 milliliters of a solution into a 100 milliliter bag, that's not. That's going to be 15%. So what we would do is we would withdraw 15 milliliters from our solution prior to injecting the drug into the bag. So, like I said, if we're going to add 15 milliliters, or in this case, we'll say the order was for 300 micrograms, into a 50 milliliter bag, we need to take that out. Because if we put 15 over 50, that's actually 30%. So we're way, way out of concentration range. Now, this is important because in this case, if it's mixed properly, we have 300 micrograms in 50 milliliters, which gives us a dose of 6 micrograms per milliliter. So if the patient was supposed to receive 1 microgram per minute, we would be able to convert the minutes to milliliters. If the 15 milliliters was not removed, the concentration would end up being 300 micrograms in 65 milliliters. So that would give us a concentration of 4.6 micrograms. So that could have an effect on the dose base if we're giving it according to micrograms per minute. In addition to understanding basic math principles, the technician must memorize common equivalents or metric conversions. So your textbook has several charts, and most of these you learned in math and practice in 106, in 102 and 106 as well. So like 1 teaspoon's 5 milliliters, 30 milliliters is 1 ounce, and so on and so forth. 1 liter is 1,000 milliliters. Also important is your standard and military time conversions. We document using our international or military time. All right. For dosage calculations, begin the calculation process by determining what? We're going to need the concentration of the drug that we're beginning with, or the dosage strength. All right. Standard time is called what? That would be clock time. So if you look at the clock, and right now it is 8:47 a.m. That would be standard time.